Hey everyone, and welcome to part 8 of the top-down shooter tutorial in Godot. My name's Joe, and we have some cool stuff coming up in this video. You're going to learn how to add AI to our enemy, how to make the enemy shoot at the player when the player gets close enough, and then how to use a finite state machine. Let's get started. Alright, so let's make our game actually feel like a game. So the first thing we're going to do is come into our enemy scene, and we are going to add a node2d, and we're going to call this AI. And the idea here is that we want to have our AI also be something that we can compose, and eventually we might have different types of AI. For now, we'll just have one, but as our game grows, we might want different types of AI, so different enemies or even allies act and perform different things. But we want that to be something that, is easy for us to just kind of drag and drop and edit and move around from the editor if possible. And that lets us kind of reuse as much code as we can without having, like a ton of just like inherited different AI classes. So we're going to try and take a stab at getting a system started towards that today. So we're going to make this AI script or node here, and I'm going to add a script, and I'll just add it into actors for now. And the first thing we will do is come into our enemy, and we're going to get a reference to that. So I'm going to say onReady var AI equals AI. Great. And now if I come into our AI script here, the first thing we're going to want to do is add an enum. And if you've never used an enum before, it's basically just like a list of predetermined values. They're really just a list of numbers, but you can give them names to kind of make a nice way to interact with them. So we'll just have an enum here, and this is just going to contain all of our potential states. So we're going to build a finite state machine for our AI, which just lists a bunch of potential states where the AI can only be in it one at a time. So we're going to have two for now. Just to keep it simple, we'll have patrol, and we'll have engage. And so the idea with this is that when the AI does not detect the player, when they're not close to each other, the AI will patrol around. And then when the AI does detect that the player is close by, they will start to engage the player and actually attack them. And so we can use these states to kind of switch between as the AI, detects that a player is near or not. In order to actually build our engage functionality, which is the state we'll start out with first, we need to give our AI a way to detect that the player is actually nearby. So in order to do that, I'm going to add an area 2D, and I'm going to call this, we'll call it player detection zone. We might expand this later to do detect things besides just the player. But what I will do then is just add a collision shape to this, collision shape 2D, and we're going to make this be a circle shape here. One thing I'm also going to do is just reset our enemies transform so that they're just at the center of the scene. And then, so our collision shape for player detection zone, we want this to be big, right? Because we want our enemy basically to say, if the player enters this zone, we can start attacking it. And again, the reason I'm putting this detection zone on the AI and not on our enemy is because ideally we want to try as best as we can to separate the functionality that our enemy needs from the functionality that is relevant to our AI. So an enemy or just, a soldier character sprite in general doesn't necessarily need an AI or doesn't necessarily need this specific type of AI. It really can exist just fine on its own, like it has been up until this point, without an AI. So we want to make that an optional feature that we can compose in to our enemy. Thus, it's going to all exist under our AI. So I can save that. Now we've got a player detection zone. Eventually, we might have a separate kind of controller node for each of these states, but for now, we'll just put it all in here. So let's get a reference to our detection zone. Player detection zone. There we go. Oh, man. There we go. Player detection zone. Cool. And so now what we can do is connect our onBody entered here, body entered, to our AI script. And so whenever the player enters this zone now, we can actually get a reference to it and do something about it. We can actually start attacking the player. So within this callback, we're going to want to actually set our state. So I'm also now going to let's bump this enum up to the top, and do that. Let's give it the proper spacing. And then what I'm also going to do is say a var or set a variable to contain our state. So we'll just say state, and then this will be we can say patrol by default. And so what we can do now is then have a function. So function. Actually, let's use a setGet here too, because we want to make sure that whenever our state changes, we're always calling this function. So we can do setGet set state, and then so here we can say set state. We'll say new state. And so this is going to be an integer because, like I said before, enums are actually integers under the hood. They're just a way to interact with a predefined set of values in a nicer way by giving them a name. So let's build this out. And basically what we want to do is if new state, let's call this current state for now. If new state equals current state. So if they're the same, we don't want to do anything. We just want to return. Otherwise, we want to set current state equals new state. We're also going to have a signal that we use to actually communicate to our enemy that the state has changed. So let's create a new signal up at the top here. So say signal state change. We'll pass in our new state. And then here we will emit signal state change with our new state. One thing I did notice too is that we didn't actually name our enum here, so you don't have to do this, but it is kind of nice to do. So you can give an enum a name. Typically you want the name to be Pascal case, where your values are actually uppercase with underscores in between. And now we have to do state.patrol. I can type this as an int, and then we just get a little bit of better type handling around our current state. So now we've got a signal that we'll send up with our new state, and this will allow our enemy to actually listen to our state changes. And what we're probably going to want to do eventually is have like some kind of a function like get new target or something, so that our enemy, when it realizes that our state has changed, it can tell our AI to generate a new place to go to, or a new position. But we'll get to that in a sec. Okay. So one thing we'll need to do before we actually implement our player detection is actually save off our player somewhere. So I'm going to add a variable just called player. We'll give this a type of player just for now, and then we will set this to null initially. And so this will start as null, and then we'll fill it in with our actual player once we detect it. So now we're ready to actually implement player detection. One thing we're going to need to do before we write the actual code in that function, though, is add our player to a group. So if you select our player in the scene tree and come over to node, not only will there be the signals tab, but there'll also be the groups tab. And this is where you can add any scene to a specific group. So I'm going to add this to the player group, and then I'm going to add our enemies to the enemy group. And the reason for doing this is because you can use groups to identify what types of things nodes are. It's very similar to tags in Unity. And the reason we want to do this is because within our AI here, we don't want to just check whether the player, like this body that we have, is of type player. Maybe we change that later on. Maybe there's multiple players, or maybe we want to use the same code for detecting AI-controlled allies as well, or just an AI that's on the other team. So what we can do is use groups to detect, is this something that I should attack, basically, for our enemy here. And I know that we just made a group called player, but eventually we can make a group called allies or something, and then we can add allied units, basically, to that group. So this just gives us a little bit more flexibility. Groups are a really easy, powerful way to kind of determine what how to handle a certain thing that you've detected without actually needing to know what type it is explicitly. So it's just a little bit more flexible. So we can say if body dot is in group, built-in function there, and we just pass in the name, which in this case was player. So if our body is in the player group, this condition will be true. So I can come into our AI script again. And if that's true, we can just say set state. Whoops. We'll give it our new state.engage. So we found a player. We need to engage. And then now that we have that, we can also set our player variable to be body. Okay, so now when we detect the player, we will save it off, and then we can use that to actually start attacking it. So somehow we need to get our weapon accessible from our AI, because our AI needs to tell our weapon to shoot. So that leads to another question, which is how do we get our AI and our weapon to talk to each other? We've talked about the idea of signaling up and calling down, but how do you make things communicate that are at the same level in the scene tree? And so one thing you can do, and there are many ways to do this, and I'm not saying this is the best way. One potential way you can do it is to still use signal up, call down. So our AI would send a signal up to our enemy saying we need to shoot, and then our enemy would tell our weapon to shoot. It's not bad. It's kind of overkill. It's adding 2 extra layers of stuff for something that you don't necessarily need. So my favorite way, when it makes sense to do, to interact scenes that are in the same level of the tree, is to use dependency injection. And what that means is that you inject a dependency, which in this case would be a scene like our weapon. So we give it to our AI at one point so that it can directly access it without actually knowing where it is in the tree. So if our weapon moves somewhere else in the tree or whatever, it doesn't matter. We've already got a reference to it in our AI. And so it gives you a method or a way of accessing a certain node without actually relying on its position in the scene tree. And that's what we want to avoid, is relying on where something is in the scene tree. So let's look at how we can do dependency injection in this case. So if I come into our enemy script, I can get a reference to our weapon. Say onReady var weapon, which will be weapon. Okay, there we go. And then what I can do is within our ready function here, so I can say ready, what we will do is say something like AI set weapon. Now this function doesn't exist right now, but we'll create it in a sec. And basically what we're doing here is saying it's okay for our enemy to know that we have a weapon. Our enemy should always have a weapon. And then if there's a case where it doesn't, we can add some handling in for that. But our AI, however, should not rely on there being a weapon. And so our enemy can actually pass our weapon in to our AI, and we will write our AI in a way so that if there is no weapon that it's given, then it'll just not really do anything, but it won't cause an error. And that gives us some flexibility, and we don't have to rely on like our scene tree being structured in a certain way. So I need to create a set weapon function on our AI. So I'll come into here, and we will just have a function set weapon, and this will take a weapon. I don't think we gave a type for that. No, we did not. So I might go do that and for just a second. So let's give this class name weapon. Come back to our AI. Now we can actually type this as a weapon. And the fact that we're having a bunch of extra references in here that in general our state itself doesn't need, but really just like in engaged state where we're attacking the enemy, makes it think that, or makes it seem like to me that eventually it might be worth it to break out, like I had previously said, to like a engage controller, or to have a specific controller for each type of state so that it can kind of handle all this, and our actual state controller, our AI controller, just handles switching states and then reporting that back to our enemy. But this is fine for now. Don't want to get too complicated where we don't need to. So now we have this, which will let us set a weapon. So I'll say var weapon, and this will be null, just like our player. And then here we can do weapon equals weapon. And because they're both named the same, I can do self.weapon. So there we go. And now what we can do is that whenever we fire or are going to fire, we can just check if our weapon's there. And if we're in the engaged state but we have no weapon, we can just, print something out like, hey, like you can't do this, and it'll just be a no op, so it won't cause our game to crash. Okay, so now that we have a weapon, I think we are ready to actually start firing. So let's do this in our process function. So I'll just say process. And again, like there's more efficient ways we could do this. Like instead of doing this every frame, we could just listen to like maybe a weapon, like weapon is ready to fire or something. But not really that important. So we can just start by doing a match statement here. So a match is like a switch statement in other languages. It basically, you give it a value to match on, and then you give, it's like a if statement, but you're only comparing one value. So we can do a match on current state, and then we can say if state dot patrol. So if we're in the patrol state, we just pass. We'll just do nothing right now. But if we are in state dot engage, we will do something, which I'll do in a minute. And then Godot's like default handling, whereas if you somehow get a value that doesn't exist, it's just this underscore right here. This shouldn't ever happen because we are using current state, which should only be one of those, but here we can just do like a print error, print error. Isn't there a print error method? Okay, we can just do print. I'll just say error found state for our enemy that should not exist. Okay, so now we can actually add handling in for what happens when we're in the engage state. So at this point, we can assume that we have a player, but we'll need a check. So if somehow we've gotten into the engage state and we don't have a player, that's a problem because we can't engage if there's nothing there. So if player does not equal null and weapon does not equal null, then we can do something. I'm just going to add this here just so we have good debugging so we can see if something like this happens. I can say print in the engage state, but no weapon or player. So that way we can see if nothing's happening, it'll at least tell us why nothing's happening. But now we're ready to actually fire at our player within here. So now if I type in here, weapon.shoot, we can run this, but we're going to notice two things. One is that when we enter the sphere of detection, or the radius of detection, it works, but our enemy, there's no bullets being shot out, and they aren't turning around to face us. So we're going to fix both those one at a time, and we'll start with the facing the player. So we're going to solve that problem also by using dependency injection, and basically from our enemy script, the enemy will pass a reference to itself into our AI. And in this case, I think it's okay to do that because our AI, like if we're trying to follow composition and kind of like a, older school, like how Unity has worked model of doing it too, like we really don't want our AI, or in this case, our AI is really just like an extension of our enemy's functionality. So if I come into our enemy, I'm actually just going to change set weapon to be initialize on our AI, and it's going to pass in, so our enemy will pass in itself and our weapon. And then on our AI, I'm going to change this to be initialize. That's like kind of a default name I give to dependency injection functions like this. It's kind of like an unofficial constructor that I use. And I'll call this just enemy, or we'll call this, let's just say actor. And that will be, actually it doesn't really matter. So we can just do that. And then we can say self.actor equals actor. So then this way, like any generic actor that needs AI can initialize this. And so there is a function in Godot called getParent we could just use, but I still like doing this a little bit better because it means that our AI is not necessarily tied to being a parent of the thing it should help control. So I'm gonna add another one in here. We'll save our actor and we'll set this to null. Okay, now what we can do is we can say before we shoot, we can actually set our actor's rotation to be the angle towards our player. So I can do rotation. Oh geez, I can't spell today. Rotation equals, and we can say actor.global position dot direction to, and then here we can do player dot global position. So we're saying get the direction from our actor to our player and then rotate our actor that way. Oh, and I also forgot, we'll need to rotation. It's a float, so we'll need to say dot angle here to actually get the angle of that direction. Okay, now if I run this, we should see that our enemy turns and follows our player. It's pretty quick right now, so we definitely, like, it'd be nice to add some kind of an interpolation to that, but it works. It's good enough. So now we can move on to actually getting the bullets to spawn. And in order to get our bullets to spawn, I'm actually going to make a change to how bullets currently work. So what I'm going to do is create a new directory in our tree, and I'm going to say globals. And this is usually what I call, or where I put global signals or global enums or just like a lot of auto load scripts. And so what I want to do is actually make a global signal for firing a bullet. And that way, there's just one signal that can be called or emitted from anywhere when a bullet fires that our bullet manager can listen to. And that way, we don't have to worry about connecting to like a bullet fired signal on our player and on our allies and on our enemies and basically anything that could fire a bullet. So normally I try and avoid global signals whenever possible because there's usually a better way to do things, but not always. And I think that this is a good example of where having a global signal for that is not a bad thing at all. So I'm going to right click on this, add a new script. I'll just call this global signals so it's clear what we're doing with that. And let me open this up, global signals. And all I'm going to do here is just have a signal, which will be bullets fired. And I'm going to basically take a cue from what we're doing in our player. So we have the bullet, position, and direction. Okay, so let's add all those in here. And now what I'm going to do in our main script is instead of connecting to our player's bullet fired, what I'm going to say is global signals dot connect. So we have to connect on global signals because that is where that's like the namespace that our signal belongs to. And we'll say bullet fired, and we'll do the same thing. Like we're still calling our bullet manager. Oh, whoops, and I actually need to add that as an auto load. So if I go into project settings, auto load, what I can do is give path to globals. This will add basically, you know, this global object named global signals. So I can do that. And now if I retype this, you should see that it picks it up. Okay, so whenever this global signal gets fired, our bullet manager will spawn a bullet, go in that position, or at that position in that direction. I'll need to edit our player to do that as well. So I can actually get rid of those. And where's our shoot? Here we go. And instead I can do global signals dot emit signal. And I say fired, or whoops, I should say bullet fired. Okay, so this should still just work as it does for the player now that we did that. So we're just using that global signal. And then now for our enemy, when we shoot from our AI, what we can do is actually call that global signal now. And actually, if I think about it, previously we had our weapon where even that had a weapon fired signal. So I think I might actually change this so this just calls that global signal directly. Yeah, let's try that. What could go wrong? I feel like that's famous last words, but let's try this. So we'll just say bullet fired. And then now I can actually just get rid of really like all this in our player. So you can get rid of the shoot function in the player and just call weapon.shoot, and that's all that you need. We don't even need to connect the weapon fired signal on our player anymore. So I'm going to get rid of our player's ready function, and we should be good to go. So now our weapon, whenever any weapon in the game fires, it is going to emit a signal for the bullet that it fired. So now we can, I think this should be good to go. I think we can try running this. Looks like I can still fire, which is good. And if we get close enough, oh, let's go. Look at that. So our enemy can fire now, and our player is getting hit. This is awesome. And we haven't implemented player death yet, but this is great. So now we've got something where it's really easy for us to implement anything really that needs to fire. We've got a basic AI that all of our enemies can use. And going forward, there's some changes we want to make, like our player or our enemy should stop firing at our player after it's a certain amount away. And we can add some basic like patrol behavior to our AI so that when there's no player nearby, it'll kind of just pace around. But for now, This is sweet, guys. I'm really excited about what we have, and even just this small thing, like now it kind of feels like a game. Like there's an enemy we can kill that fires back at us. So I'm really excited to keep going and keep adding more features to this.